Welcome, everybody, and thank you very much for joining us for this webcast seminar titled Leveraging High Fiber Count Documentation to Automate Tier 1 and Tier 2 Testing and Reporting. At Cabling Installation and Maintenance, we are pleased to offer this seminar to you today, and we thank our sponsors for the event. They are Electro Rent and EXFO. We're greatly appreciative to them for their sponsorship. The seminar is going to be delivered today by EXFO's Senior Application Engineer, Kevin Pearies, with an introduction from Alon Pendon from Electro Rent Corporation. So we thank them very much for being here today and for delivering the information that you're going to see. A little bit of housekeeping to our attendees today. First, the question button that's on your screen, or the question window that's on your screen, is how you can send questions to Kevin at any time during today's event. We'll have a Q&A with Kevin to wrap up after his presentation is completed. Also, that question button is where you can send any tech support inquiries that you need. We've got some help on the back end of things here. If things don't sound right or don't look right, then we might be able to help you out. Use that question button to let us know what's going on, and we'll see how we can help you. Also, if you can close other applications on your device while watching and listening to this, that would be helpful. This webinar platform does operate optimally when it is the only game in town, so to speak, on your device. So we appreciate that very much for best performance. To those of you who are regular attendees of our webinars, we appreciate your attendance very much. And I want to bring up a BIXI continuing education credit and the status of that. Please know that for this webinar, we have applied to BIXI for a continuing education credit. That application is under review. And if BIXI does give us the go-ahead and allow us to offer a continuing education credit for this seminar, then those of you attending live today, no further action is necessary. We will follow up with you with an attendance certificate that BIXI would recognize for a CEC. So again, that application to BIXI is under review. We do hope for a positive outcome from them, but please know that because you're attending live today, you don't need to take any further action. If we do receive the okay from BIXI, then we will follow up with you. We'll deliver an attendance certificate to you, and BIXI will recognize that an attendance certificate for a CEC, assuming that they do approve this seminar. So thank you for bearing with me through that housekeeping. To begin today, I want to introduce Alon Pendon with Electro Rent, who's going to offer a little bit of an introduction to that organization, its offerings, before turning it over to Kevin. So Alon, the floor is yours.
Thank you so much. I appreciate it. Hello, everybody. I hope everybody's doing great today. My name is Alon Pendon, and I am the Digital Demand Generation Manager at Electrorent, and we are excited to co-sponsor this webinar with EXFO today. But before we begin, I wanted to tell you a little bit about Electrorent. So Electrorent is the largest global provider of solutions for test and technology. We manage $1 billion worth of inventory, which includes more than 95,000 units across 200 manufacturers, including EXFO. Our reach is pretty extensive, but what truly sets us apart is our depth. We've been around for 60 years. We have 500 people worldwide and specialists who know how to keep your projects moving forward. And we help a leading global organization save millions in equipment while giving them the flexibility to test and scale without the burden of ownership. Now, while our footprint is global, our support is always local. We have teams in every major region backed by both in-house expertise and close relationships with OEM partners. And that means fast delivery from our regional centers and the ability to do business in more than 100 countries. So wherever you're working, you'll find an Electrorent team that speaks your language and understands your market. At the heart of what we do are flexible solutions. So for many customers, rental and leasing are smart choices. That means you only pay for what you use without no upfront costs or CapEx, and you get immediate access to our global inventory. If you need to buy, though, we got you covered as well. We're an authorized distributor for new equipment, And we also offer certified pre-owned gear that goes through a 23-point quality check and comes with a 1-year warranty. And on top of that, we help organizations optimize the assets they already own, giving them real-time visibility, saving both CapEx and OpEx. So in short, we give you independent advice, flexible options, and the confidence that you've always got the right equipment at the right time. So thank you so much for listening to me today, for your time today. If you need more information, I encourage you to visit goemail.electroret.com/DC, which you see in the screen right now. So, and now I think it's time to turn it over to the star of the show.
Good deal. Thank you
Over
very
to you,
much.
Kevin.
Right. Thank you. I appreciate it. Let me share my screen here. Give me a second while I do that real quick. All right. Perfect. And here we go. So again, my name is Kevin Pierce with EXFO. I've been with EXFO for about 22 years, but I've been in the industry since about 91. So I've been around for a bit. So a lot of my training, if you sat in on it, is a little interactive. So that's why I like to share my screen and do a little bit of drawing and have my image up there. So today's session, we'll be talking about how to leverage, some of the automated tools and documentation for high count testing. So we'll talk about some of the challenges. We'll do a high level of the different type of testing that we're commonly looking at when we're testing fiber optic cabling within a data center, within a hyperscale, or just fiber in general. Quite honestly, so I'll go ahead and step through that. And I see we have a really good turnout here today. So I appreciate everybody taking some time out for this event. So essentially, we'll talk a little bit about fiber connectors, right? So most times when I do a presentation, I like to talk a little bit about the perimeter of the things, right? What's underneath, what's driving it, what activity is happening that we need to have, or we need to start looking at some sort of automation or some sort of more intelligent testing. And so we'll talk about things like the different types of infrastructure out there, and some of the different types of testing. And then at the very end there, we'll get into some of the automation and the reporting aspects of it. And really, this is more of a topic that I've been talking about here a lot recently, just to open up the conversation. Um, and a lot of us are drinking from a fire hose with the amount of fiber that's being deployed today. Every time I think that there's a lot of fiber in the ground, we one up ourselves, and now we're looking at very high count cables like 6912 and the like. So when I was splicing, a 96 was a large count fiber back when I used to splice. So obviously a lot has changed now. And so when we're talking about that, I'm not going to be talking any specific standards today, right? Not in detail. So some of the values that I might use during the presentation are not specifically tied to a specific standard, but it is important to know that they live out there, right? Whether it's a TIA standard or an IEC standard when it comes to things like color codes and threshold values and type of testing. We'll cover some of that, but I'm not talking to any specific type of standard. And so as I look at the slide, it reminds me of a conversation I had as a former splicer. There's always that conversation here in the US about, is it rose or is it pink? Is it slate or is it white? And part of where that comes from is based on standards. So IEC is more international. In France, rose is pink. And so that's the word they use. And of course, it's an international standard. So that's where we start seeing terms like that come in, where some of the OTIA stuff used pink, right? Or, and so that just reminded me of that conversation is all. And so, from an aspect percentage perspective, we'll be talking a little bit about multi-fiber connections and what we see out there. And so there are different types of multi-fiber connectors out there. We'll cover a few of them. They're ever changing. The density is getting tighter and tighter, and that's really the main focus I want to talk about when it comes to connectors and stuff like that, because things are getting very tight. And what I mean by tight is density. And so I remember when LC connectors first came out, and started being much more prevalent on the telco side where I came from. And I remember my big pause and looking at those panels, thinking to myself, I'm going to cause an outage. Right? They're just too packed. Now we fast forward today where we're really getting some really high density with some of these panels. So depending on the type of connector you're deploying, we're starting to, I mean, obviously MPO and multi-fiber connectors in general have been around for a while. But now we're starting to see, even smaller form factors, right? So very small form factor. So that VSFF here that you see up here, this is a term. If you've not seen it, you'll be seeing it a lot more. So those of you that are working, some of the hyperscale or larger density data center deployments are probably very familiar with some of these connectors. And they're not only for multi-fiber, there's small form factors for single fiber as well, but really focus on multi-fiber. So if you look at, say, a standard, MPO base 12 connection, we get about 864 fibers in a 1 RU. There's a lot of connectors, a lot of fibers in a single 1 RU. But as you start to increase the count of the connector to, say, a base 24, so MPO 24 or the like, then we start getting even more fibers into a 1 RU. And so as that connector gets smaller, more and more density. So you start looking at things like base 16 and base 24, which we see a lot today, such as the MMC 24, we can fit over 6,000 fibers in a 1 RU. And so just from a just capacity or density perspective, that's just a tremendous amount of connectors. So if you consider 1 RU loaded with base 24 multi-fiber connections, and start thinking about, if you're a tester, how much time that is. If you're doing fiber inspection, how much time that is. If you're a splicer, how many fibers you have to burn. If you're doing analysis, how much, you know, data you have to look at, and scale this by the cabinet, scale this by the relay rack, and scale this by the building. It starts to get, pretty mind numbing if you start thinking about it. And so, just again, some of the primers, some of the fiber basics here. Again, I like to put this in there just for completeness. And also, when we provide the PDF, I'd like to have all this extra information in there because I think it's useful if you want to review it, right? We're not going to go over any of this in great details, but obviously we have different color codes, multi-mode versus single mode. One thing that we're starting to see that is different from this slide that I haven't really updated yet is, traditionally, when I was working with a customer and they told me they had a single mode multi-fiber connection, such as an MPO, I first thing I go, okay, that's an APC connection. If they're doing multi-mode, that's a UPC end phase. We're starting to see now multi-mode APC in some recent deployments. So obviously it's more of a manufacturing difference, right? As far as it isn't a technology leap or anything like that. It was just something that we had not seen. So that's something we're starting to see. So from a testing perspective, keep that in mind as you start to look at your different tools, as you start to look at your different panels and stuff like that. That there are different options out there today, and things are ever changing. So a lot of the vendors out there are coming out with some revolutionary products and methods. So keep it up on that, and sessions such as this one that's provided a lot by Cable Installation is great to sit in on and learn. And of course, we have the different color codes. And so again, this is just for kind of the background primer. We're not going to get too deep into that. As far as the connector styles, again, we're starting to see this very small form factor. The LC duplexes are getting smaller and smaller. Now we have things like CS and SN and different versions of connectors by different manufacturers, right? And so just understanding that we have that, and of course that's not just for single and duplex fibers, but also for multi fibers. And this is ever changing. And of course with MPO, we can go more than 24, right? We can go higher than that. And so, it's important to understand the direction that we're going, and just the amount of density that we're starting to see within our network today. So that's what's really driving this conversation here today. And again, I like to have this all up there within the deck, just so you have this information when we provide you the PDF. One thing to take into consideration, and I decided to add this because reporting is a big part of this conversation. And one thing people don't really realize is, as we're starting to use fiber inspection probes more, right? We should be using it every single time. But a lot of companies traditionally have not mandated any sort of reporting for fiber inspection, right? They always mandated that it must be done. But a lot of the customers I work with didn't have a process in place to document the results. We're starting to see that big shift now. And so now we're starting to see a lot of documentation. One thing to keep in mind is on these fiber inspection probes, there's going to be different layouts. And so setting the appropriate layout and understanding the pinning is important. So on multi-fiber connectors such as MPOs, there might be an offset in the key to denote whether it's a 8 to 24 or 16 to 32. You can kind of see the offset here, right? But there's also going to be, different options for the pinouts as well. And so as we look at that, it's important to understand that. And so I have another slide later on that talks about that. But knowing the orientation or the layout of these actual pins, which is number 1 and which is number 12, which is number 1, which is number 24. If you have the layout, pin up or pin down, frogged or transposed, it's going to flip your first and last fiber number. And so on your documentation, you're going to be off. And so that's important to understand. And so, there's some of those considerations to make. And what's driving a lot of this? Parallel optics, high speed connections. When I was a technician, I used to work, I had a lot of different hats when I was on the provider side, but I did work for a long haul provider at one time. And I remember OC 192, 10 gig sonnet was the big bandwidth, right? That fed cities and states and some countries. Now we have 10 gig, theoretically to residents. I live outside of Phoenix, Arizona, and I have a 2 gig symmetrical fiber connection to my home, which is just mind numbing to think about. And so but when you start providing bandwidth like that to your end users, you start to need more bandwidth. A lot of the bandwidth right now we're looking at is really for a lot of AI clusters, is where we're seeing a lot of this happening right now. Now, this sheet right here is not all inclusive, but it's many of the parallel optic types that I'm running into today. And so basically I've broken it down. Well, I got this slide from somebody else within our organization, but I've changed it a little bit. But if you look at some of the optics that we're seeing today, right, we're seeing a lot of things like 800 gig DR8 and those types of things. And if you look at it, it's it's a parallel optic, but it uses 16 fibers. So essentially, there's going to be 8 transmit and 8 receive. So those of you that splice, you're probably starting to see 16 fiber ribbons. This makes sense because if we were to use a 12 or a 24, so for 400 gigs, it would use 8 fibers. And so, of course, then you'd have 4 left over from a 12 fiber ribbon. And so 16 works great because then also it's 16, 32. And so it scales a lot better with parallel optics. And so this is why you start seeing connectors like MMC 16 and 16 fiber ribbons is to support parallel optics. It'll be interesting to see where we go with multi-core and how multi-core will interact with this, a 4 fiber multi-core. That's a whole separate session that I've done on multi-core and hollow core. But really, parallel optics and these high speeds really was driving a lot of this high count density, and particularly in AI cluster type environments. And so there's a big migration to parallel optics. And so if you're running 100 gig, if you're running different types of high speed optics that use technologies like CWDM to manage the different lanes, then you're probably using duplex connectors, right? And so this is a very common deployment that we see within a data center where you have an MPO trunk. In this case here, it's a 24 fiber MPO trunk. It's feeding 2 LC cassettes on either end. So you're going from single fiber duplex to multi-fiber, right? And so this is a lot of what you're testing today. So your standard single fiber OLTS shines in this environment. So your power meter source type of testing, single fiber, this is what we've been doing for quite a while. But as we start changing technologies and shifting over to parallel optics, we'll remove those single port LC duplexes that are in those modular cassettes. And then all of a sudden we're going full MPO. And so this is what we're seeing a lot of now. This is where we're getting our density, right? Is going to multi-fiber. In this example, it's MPO, but it could be one of the very small form factors as well. So now much higher density, as we talked about earlier. And so this drives a lot of that that need right there. And so now this section here changes a bit. And this now is what we're focusing on and what we're testing on today. We're seeing a lot of this. And so, those of you that have been doing traditional single fiber testing are now struggling with breakout cables. Or before, you might have had a breakout cable, or in this case here, you have a breakout cable the other direction, where now you have 12 fiber breakout into a multi-fiber connection. It's not a very efficient way to test, but that's some of the challenges that we're running into here. Um, and so, from a fiber inspection perspective, of course, being able to scale up to be able to inspect these connectors better. So, a lot of traditional fiber inspection probes, including our traditional fiber inspection probe, really shines for single fiber, but is really challenged for multi fiber. Obviously, there's newer fiber inspection probes that are much faster, that handle this better, that have more intelligence for reporting. So it is important to do fiber inspection, and we're seeing a lot more requirements for reporting. And if you can imagine the file size of these high resolution fiber inspection probes, so the really good fiber inspection probes use very high resolution to maintain repeatability and consistent pass fail results. You need high resolution, right? If it's a little grainy, then you'll kind of get, your some uncertainty there. But because of that, the file sizes are much larger. So that's another challenge that we're having now is all of a sudden we have fiber images, fiber inspection images for multi-fiber that is each file size is a couple of megabytes. And you scale that by 6,000, 10,000, 20,000. That's a lot of data. And so how we interpret those results is going to be a challenge. And so that's one of the things that we see from a fiber inspection perspective is how do we do that? Maybe it's more intelligent reporting. So I do a lot of custom reporting for EXFO. I build a lot of custom reports. In fact, I'm looking at the list here for many of the customers on here right now. Um, and it's, I have a new custom report that I just built that doesn't even include the fiber images anymore, because who's going to look at 20,000 images? AI might at some point in the future, but we're not going to, right? We're going to look at a table of results, and we're going to focus in on the fails, which I'll talk about a little bit more later. So I don't want to steal that thunder. Um, and so obviously the connectors come in different configurations. So it's important to understand that when you are inspecting the fiber, that you set the layout correctly. 8 fiber, 12 fiber, 24 fiber. Because if you're doing 8 fiber and there's 4 dummy fibers in there or 4 dead fibers in there, you don't want to inspect those, right? You want those to be ignored. So having that kind of a consideration is important to understand. That way, you're not getting false fails. So being able to analyze the data efficiently and switch between different connector types is incredibly important. I included this because this is more for test efficiency, right? We're talking about leveraging high count documentation more than anything. But really, if you think about it, increasing your test efficiency really adds to that overall experience of kind of speeding up that testing, which I know a lot of us on the call are concerned about as well. And so the 2 most common test types we'll talk about here, that we'll talk about with automation in particular, because we are talking fiber optics more than anything else. First one is going to be the tier 1 testing that we're doing today, which is a light source and a power meter. So some sort of optical loss test that are OLTS testing or OLTS testing. And so these are defined by, there are different standards out there that may define the referencing type, the method of testing, whether it's, you have to use loopback, side by side, single chord reference, whatever it happens to be. There are different types of standards out there that are related to that. There's different types of sources and different capabilities of the OLTS. But tier 1 basically testing is OLTS, power meter source, power in, power out. And we'll talk about some of the strengths and weaknesses to that test methodology. And so traditionally, again, this is just a single source that was testing, 1 fiber. And you have a source on one side. You have a fiber light source on one side. And on the other side, you have an optical power meter, right? Just doing simple loss testing, referencing it out, testing each fiber one at a time. That's your traditional testing you've been doing for a very long time, whether in the telco space or the data center space or the structured cable space. It's anybody in the fiber space. This is something that we've been doing for a long time, right? And so there's that. And then, of course, plugging that in. Um, oh, look at that. I hadn't frogged. I didn't even notice that. So port one. And so this must be a type B. This must be a type B um, connectors, which we'll talk about when it comes to polarity, right? And so basically, this is the testing that we've been doing for quite some time. So using just the standard OLTS that you can set configurations for based on a standard or something like that. And the reason why I bring this up is because having the capability to set your thresholds intelligently all adds to the automation portion of the reporting, right? So the more information that you can get right in the field, and as that propagates into the cloud or into your automation system to create these reports, getting the identifiers correct is important. In fact, that's one of the biggest challenges that we've had for high count testing, quite frankly, is a technician sitting in front of a test set typing in identifiers. And right now, particularly in the AI cluster space, I'm working on identifiers. So when I was a tech, it was location A, location B, and then my fiber ID, right? So Goodyear to Phoenix, fiber one, fiber two, fiber three. That was my file naming convention. Very simple. Now we have naming conventions. I have a customer I'm working with now that's right at 70 characters, right at 70 characters. And I never thought we'd get close to that limit. So one of our test sets that we have that we're looking at, it has a 70 character limit, which is a lot of characters. I never thought we would get close to getting to that max character limitation. And so now we're looking at increasing that even more, right? And so because of that, being able to set configurations and intelligently set up your test set in the field will cascade upstream as you're doing your automation, because then you have that information is parsable, right? And so we'll talk about that later, but there's some bidirectional pushing of that type of activity that we have here. And so there's some additional slides in here. I won't go through all of them because I like to provide these because when we get the PDF, I think this is useful information to have. That kind of shows the interface, that shows the importance of referencing and those types of things. But we don't need to step through every single one of these interfaces here. And so, but that's for single fiber. So as we transition into multi-fiber now, high density testing, now we start to see different types of challenges, right? You don't want to be doing single fiber breakouts to test this type of infrastructure because it's going to create a lot of files, first of all, a lot of time, and a lot to really digest when you're doing reporting. So you want to be able to connect at a multi-fiber level and test the entire multi-fiber connection, in one sitting. And so this is where we start to see things like multi-fiber uh, OLTSs. Now they've been around for a while, but now this is kind of um, you know, the big wave. If from our perspective of testing, is we have these multi-fiber uh, testers now, and they're designed really specifically for data center, AI cluster, um, tier one testing. So anybody who's doing standards testing like TIA, structured cable, those types of environments, this is really where where something like this shines, and it's important to have because then this speeds up the efficiency of the testing in the field, right? And so, and obviously, you're going to be doing insertion loss per channel. So, meaning per channel, meaning per individual fiber within that multi-fiber connection, continuity validation, polarity type, and then length. So these are the four common metrics that we see for tier one testing from a very high level. And so this is what we're looking at. Obviously, with single fiber, we didn't need to do polarity because it was continuity based, right? It either lit up or it didn't light up, right? And so now we start to see those challenges as we talk about polarity and some of the things that we're seeing there. And so, especially in the very beginning, polarity was a huge issue. It still is an issue and something to be wary of. If you're using or interfacing with different customers, like in an interconnect situation, and you're handing off multi-fiber both directions, are you both on the same polarity? I have MPO connections in my office here, so sometimes when I'm doing a demonstration, I pick up the wrong one with the wrong polarity, and I'm not getting continuity, and then I do a quick test and I say, well, I got a type A and a type B, right? And so understanding and dealing with polarity is important, and it is part of the tier one test suite, right? And so, as I mentioned, uh, testing for polarity, especially if you have multiple fibers and multiple polarity situations in your office, or if somebody's ordering it, right? So if you place an order with your procurement department and say, I need 100 multi-fiber 12 jumpers. If you didn't specify the polarity and they get onto their vendor's website to purchase it, they go, oh, this one's cheaper. That was cheaper because it's a type A and instead of a type U or whatever it happens to be, right? And then all of a sudden you have a stock of jumpers with incorrect polarity. So being able to check polarity and understanding that's very important to do. And so understand that there are different types of polarities out there. So type A is straight. Blue goes to blue, orange goes to orange, rose or pink go to rose or pink, right? Type B is reversed. So 1 to 12, etc. Type C is cross, and then type U is interesting. It's universal. And so basically you have one universal polarity that you use in your infrastructure, and then it's managed with modules or something, or some sort of breakout to convert it universally for you. I'm not seeing a lot of that yet. I've seen a lot of A and Bs, mostly A's, but understanding that there are different polarities out there and testing that's important to understand. And I mentioned earlier the key orientation, key up or key down. So on on MPO connector in particular, there's a white dot. Wherever that white dot is, that's the side that fiber one is on. And so in this case here, fiber number one is right here, right? And when you're inspecting with a fiber inspection probe, it gives you the option is key up or key down. You want to set that key appropriately because when you're doing pass fail, if you have that orientation upside down, you're going to frog your fiber numbers. And so that's important to understand because now all of a sudden you're on the wrong fiber when you're going back and doing remediation or something like that. So that's something to keep in mind. And so with the tier one tester, being able to do that polarity test is important. That'll cascade up into the cloud for reporting. So that's important to understand and do. And so being able to look at that, getting those metrics that we're talking about, the loss, the distance, the polarity, are all important considerations when you're testing. And so, but there's all stuff you also got to manage, and so the more information that you get from a low level as it propagates up into the cloud, into your reporting tools, you can see the complexity that we have to deal with, right? The different namings and things like that. And of course, we have tier two testing. So tier two testing is traditionally OTDR, IOLM testing. Again, we still have the single fiber perspective stuff that we're looking at. But really, what I want to focus on is where it really shines. Where it really shines is looking at specific locations. So if you're doing loss testing across this span, and you have 10 dB of loss when you expect 8, well, an OLTS is not going to tell you where the problem is at. That's where a tier two tester is involved. An OLTS is also not going to do reflection or ORL traditionally as a tier one tool. There are OLTSs like our OLTS for single fiber does ORL and reflection. So it does measure that. But a traditional source and power meter OLTS does not. And reflection ORL is essentially noise. Right? This is a big noise generator within a fiber optic network. I'm oversimplifying that, but that's the biggest problem that we have with reflection and ORL. And so knowing which connector is dirty is important. I have a video, if you ever look on the web, it's called Cleaning a Connector with an OTDR. Just search for that. And I talk about how to use an OTDR to troubleshoot connector cleanliness, right? And so an OLTS will tell you if there's high loss on the span. An OTDR will tell you if there's high reflection and where it's at, right, as well. And so knowing that is important. One challenge that you're going to have is with an OTDR, not to get too deep into it, and just because I do an OTDR course, the distance between, in these modular FTP panels, we have a connection here, and then we have about 1 meter of fiber in here. This will vary. And on the back side of the module, we have the multi-fiber connection. This is a possible layout. If this is 1 meter apart or less, an OTDR or IOLM cannot separate these two. So, from a troubleshooting perspective, although it's not part of this course, as a troubleshooting perspective, if you're getting high loss and high reflection here, and you clean this connection, clean it, and it's not getting any better, it could be that your problem is here. It could be the second one on the backside. Most maintenance issues that I've dealt with when turning up a new circuit is an installation issue that was not caught during installation. Make sure this connection is fully validated in testing before you start to put traffic on this thing, because when operations starts putting traffic on this and then one of these is dirty, you got to take the whole thing down to fix that. I just bring that up because looking at this graph reminded me, and I see there's a lot of splices on here, so I think it's an important thing to at least mention. And so an OTDR will allow you to look at discrete event losses and high reflections. So that's the value there. So when we talk about it, and again, I got some slides in here that talk to that I like to leave in there. But when we talk about it, when you're doing tier 1 testing, just loss in a power meter, and you look at this particular link, you know, your total tolerance based on the spec, we need 3.06 dB or better on this span. And we tested and it's 2.19, which is a pass. We're good there. But if we look at individual events, it is possible to have a high loss event, but still pass your span. And so this is where a tier 2 tester comes in useful. And again, if you start doing more that type of testing, then that's more data to handle on the back end. And so that's important to understand. And I talked a little bit about the difference between tier 1 and tier 2. Tier 1 testing, very fast. You get to do polarity, and it uses a continuous wave source, which is a more accurate method of measuring loss. The weakness is you need to do referencing, and you can't pinpoint. You can't do distributed loss, so span loss, connector loss, those types of things. And in the OTDR, you can do that type of testing, but it takes longer, a little bit more expertise, and it's not tier 1, right? It's a tier 2 tester. So again, these slides are up here for, if you want to review later to look at the different lines in detail that I talked to. But it is important to understand that. And so this all leads us up to test automation. And there's a lot of different ways to do test automation, right? Whether it's a manual method, even though that's counterintuitive to the word automation, but there's things that we've all done here and there to improve our efficiencies, whether it's splicing, whether it's testing, whether it's hotkeys on a keyboard. Over time, we figure out shortcuts, which is kind of the field way of doing or testing more efficiently. And so test automation has become something, it's been around for a bit, but now it's become more and more important as we start to scale the count. And I know we're talking about some of these data center locations where there's tens of thousands of connections, but this holds very true for standard point-to-point testing, like we see in backhaul testing and metro testing. There's a lot of 864s, 1728s that are being deployed in the outside plant that also need to be tested. And if you add all those different spans together, if you take an 892 through a metro environment and you have 10 different spans, that's a lot of fiber reporting to manage. And so when I used to run a fiber characterization crew, I used to work for a tier 1 provider. When I ran a fiber characterization crew, one of my biggest challenges was the technician in the field entering information. And quite frankly, a lot of us techs are really good at craft and maybe not so good at administrative work, right? And I know that's a little bit of a generalization, but it was a common thing, right? But at the same time, I don't want my splicer or my tester to spend a lot of time typing in data into the test set, even though it's incredibly important. So I used to have my techs put in the basic information and I would fix it on the back end with a reporting tool or even manually sometimes, because I wanted to save their efficiency by moving some of that into the office or into the back end workflow. But that's very manual intensive. It's very chaotic in its own way. This is where test automation comes in, and this is really the crutch of it. So all the testing and challenges that we talked about up to this point really tie into this. How do we take all of that testing that we're doing, all of that high count testing that we're doing, and trying to make it more intelligent? And you'll have to excuse this activate Windows down here. For some reason, I just reinstalled. It won't take my key. So I'm not a bum, I promise. But and so basically that's what's happening, right? Um, and so we need to take all this information and we need to make it a little bit more efficient. And so that's one of the things that we need to do. And so from a network lifecycle perspective, some of the challenges that we see from an operational cost perspective. I don't know why my camera moved further away. That's fine. From an operational perspective. And so when we're looking at it here, from an operational perspective, these are some of the challenges that we see, right? Result validations, repeats and reworks, manual entry that I talked about, project management. There's all these operational costs when we're deploying a project that some of us don't always see. Project manager might see them, that's what they manage. But as a technician, I was paid by the splice, paid by the hour, whatever. I focused and my silo was this. That was my operational cost. And of course, my manager was that plus whatever they had to do. And of course, it scales up and up and up. But these are some of the challenges that we see within the system today from an operational perspective. Now, from a commercial perspective, it has its own challenges as well when we start dealing with network life cycles and where we have potential costs and potential savings. If it takes you too long to turn in a closeout package, and I got to tell you, especially a lot of the contractors on here, even the providers. So when we're looking at closeout packages, uh, from a contractor's perspective, that's doing the actual physical testing, you don't get paid until that closeout package is validated and submitted. From a construction perspective, uh, for the provider, that fiber doesn't get handed over to operations until that closeout package is given to me. I've validated and I've inputted it into the system. Right? Then it goes to operations. Then operations can monetize it by putting services. So there's a lot going on up to that point, right? So there's different operational and commercial considerations. If it takes too long for you to turn up a network, then you might have signed a contract with a customer and they've decided it's taking too long and they go along their own way. So now you have wasted CAC, customer acquisition costs, right? All the money you've spent to put that fiber in the ground, to engineer it, to install the equipment, and then all of a sudden the customer's gone, right? So all of this of potential cost savings and budgetary issues is what we really need to try to address and to reduce this churn and some of these issues that we're seeing. And so that's stuff that we need to understand. And so from a field challenge perspective, we have a lot of non-standard MOPS and inconsistent procedures still to this day. We're getting much better at it, but processes in general. Um, I'm not saying there isn't enough processes because there's a lot of processes in some organizations, which I'm all about. I used to write processes and I still do, but that doesn't always relate to, that process being followed literally to the literal intent in the field. Um, and so at the same time, you have one process that's generic that covers a lot of things. So you see, you have like non-standard MOPS and things that happen there. And so we see, we see things like just simple data transfers, getting information off the test set. I remember once years ago, back when I was testing, I was testing across the U.S. along I-80. It was actually along the railroad tracks, and I happened to be in Nebraska, which is the central United States. And my OTDR back then saved traces on a diskette. So the hard diskette, like 3.25 or whatever the size was at that time, 3.5, whatever it happened to be. And I remember we were done and then we left to go further down a couple of hours. And I was in Iowa, which is a different state. And I put that diskette into my laptop in my hotel room and the laptop chewed up the disk. So I had to drive all the way back, 3 or 4 hours just to test a dozen fibers. So that was one of the challenges we had. And so right now in the field is getting that information from the technician to the right person. Whether you got to do manual transfer via USB into an email, and then that goes to somebody, and then it sits there until whenever it's looked at, right? So that's one of the challenges there as well. And so, of course, that all adds delay. The longer it takes for that data to get to, from the field and into wherever it needs to go, that's time. And time is money, right? Time is money and time is bandwidth. And so I should get a shirt for that. And of course, there's different types of testing now. Point to multi-point, which has been there for a while on the fiber to the home side. Now we're seeing it a lot now within interconnection data centers where you might have one panel that goes to 20 locations within your structure. Even one connection, one multi-fiber connection might go to multiple locations if it's broken out. And so now we're starting to see complexities with multi-point. So now the naming is much more difficult to manage as well. And so those are things you got to look at. And then out of sequence testing is very common. When I was doing an outside plant, you started at 1, you went to 96. Right? That was it to a large degree. You didn't skip around a lot. It was new fiber. Nowadays, new fiber, you could be out of sequence, because you're standing in front of a cabinet and it's going to different places. Right? And so you're jumping around. So being able to jump around without having to get in there and manually edit the location is key. And so that's where the automation can really help with that as well. And then just a lot of data. Even today, there's a challenge in creating reports for 864 fibers. With all the images, the trace graphs, all that stuff, the files start to get very large. It starts to take a bit longer to churn through that data, and it takes a while to analyze it, right? And so these are some of the things that we're seeing. And so a lot of the traditional methods that we see today are manual, right? Excel, cut and paste, USB transfers, all of that stuff, naming conventions typed in by hand. And so because of that, that adds mistakes, right? Putting the wrong fiber ID, inconsistent naming conventions. I might call a site Goodyear when somebody else uses the actual silly code, right? And so we mean the same thing, but we're using different words, right? And so having that consistency is important. I like to type in uppercase. Somebody else might like to type in lowercase. That type of things. Those little nuances really add to the complexity of manual or traditional testing methodologies. And then, of course, sorting all that information, efficiently. If it's not already named the same, then you're doing stare and compare on your computer, and that's mind-numbing amount of analysis involved there. And of course, a lot of human error there, a lot. Because of all that chaos, it's hard to manage that much data efficiently and consistently without spending an exorbitant amount of time on it, right? And so these are some of the traditional methods that we need to try to figure out how to overcome. And so these are the challenges of manual methods, right? It's time consuming, all of that stuff that we talked about, right? So this is kind of just a recap of what we just talked about there. And so this is where we start to see, we need to figure out a more intelligent way to manage all this data. And the batch process and to get them through the system and those types of things. And to customize our reporting. You might have a different report for somebody at an executive level versus somebody at an engineering level, right? Versus somebody at a field level. You all want similar data, but in different ways, right? I don't see somebody at an executive level looking at individual OTDR traces. They might, but it's not a very efficient use of their time, right? And so, having all these things and doing data validation, error validation is important. And, in the past, this is where I did a lot of activity. So I did a lot of custom closeout packages where, if you look at this, and it's kind of hard to see here, but if you look at this here, in fact, I'll zoom in a little bit. There's just a lot of data. This is one fiber. This is one OTDR test, 2 wavelengths. Look at all that data, times, 864. You can imagine how mind-numbing that is. So I started creating detailed reports, and then I had a subsequent analysis report that only looked at the fails. Because quite frankly, I don't concern myself with what passes. I concern myself with what doesn't, right? And so I focus in on that, and I remediate that. And so this report here just tells me what needs to be worked on. I grab this report, I give it to a contractor, and I say, okay, here's what you got to fix. Instead of giving them this saying, hey, there's 12 fails, and they have to figure out where they're all at. Right. And so this is something that I've done with custom reporting that helped with this. And this is something that we can also scale into automation where it's done automatically, where when a job is complete, it's sent to the relevant, the results are sent to the relevant party that needs that level of detail, right? And so this is where automation comes into place here, where we start to look at it. Manual reporting doesn't scale, but our networks do. This is ironic because I actually got this from AI. I was talking to AI about scaling reporting about a year ago, and it gave me this line. I said, I like that line. So I should probably put in there AI as the source reference there. And so automation unlocks a lot of the things that we talked about, accuracy, compliance, consolidating the report, and scalability of it, right? And being more efficient with all that test data. Just reams and reams of test data that we need to churn through is again mind numbing, which I probably use that word a little bit too much. And so this is really to make things much more efficient that we're doing there. Whoops, wrong direction there. And so this is where we have tools like EXFO Exchange, which is our automation tool, right? And so this allows you to automate the workflow. So we have an app for the phone, we have an app for the test sets. And so the message here is, look into automation. And so ours happens to be called EXFO Exchange. And so what this allows us to do is create and assign jobs and send them to individual technicians, individual groups, right? Predefined all the areas that are controlled. The naming convention, that up to 70 characters for that one customer. Instead of them doing the work, we automate it and we push it to the test set, right? And then, of course, real-time centralized uploads. So when all the testing's done, it's pushed into the cloud. And then at some point, well, those are all out of order. And at some point, there's going to be reporting, all the data centralized. You don't have to deal with getting USB from a technician. You log in, you check the status, you reduced a bunch of emails and phone calls. And then when you do have those emails and phone calls, it'll be more of an intelligent conversation because you don't have to ask the questions like, how much testing did you get done today? Because it's right there in front of you in the cloud. You can focus in on what are you doing tomorrow? What are you going to do about these ones that have failed? Those types of questions, which are a lot more powerful. And so you streamline even the conversation that you have with all of your different involved parties that are doing the testing. And then, of course, as far as a whole automated ecosystem, this is typically what we see in a standard traditional testing methodology. A lot of manual activities, uploading USB keys, all that stuff we talked about. And then once we start looking at automation, and then a lot of this is centralized and controlled from a central location. Now, obviously, you're still going to need, people that are managing the automation portion of it, creating the jobs, pushing the jobs, analyzing the information, right? Those people still exist. They're just, doing it manually. And so now we start to automate this a little bit more to make it more efficient. Because quite frankly, there's so much fiber that, we need automation to make us, not so far behind, quite frankly. And so from a use case perspective, this is a little bit hard to see, but this is a typical process that we see, right? It's designed in the field. It's manually, inputted into some sort of database and sent out to the technician. They input it into their test set. They run the test. Somebody validates the information, stores it, creates a local closeout package. This entire process takes weeks and weeks and weeks, right? And there's a lot of manual intervention in there, right? There's a USB key sitting on a desk somewhere that has data that somebody, 2 states away needs, but they have to wait for somebody to pick it up and put it into a computer. And so this is where automation comes into place, where we can start to automate, and start to replace sections of that inefficiency. The creation of the jobs, the pushing the jobs to specific technicians, the inputting of test parameters and pass-fail parameters as well. And then, so the technician is focusing on setting up, inspecting and cleaning fibers and, hitting start. They're not, obsessing over a print, typing in information. All that stuff is automated for them. They essentially just got to sync, go to the test site, and then do the actual physical work, right? Which is really the technical part that's very important, that we want to really have them focus on, and not focus again on administrative and and driving halfway across town to hand somebody a USB key. And so, of course, and then delivering all that information and validating it in real time. So this is where the automation portion really starts to come into place, where we're doing a lot of this activity. And from a technician's perspective, they get a digitized map. This may be what it looks like on the test set. Go to this location, hit this button and test fiber inspection, hit this button, test fiber inspection. So all they're doing is doing almost like a whack-a-mole. And so for those of you that are international, whack-a-mole is that game where the heads pop up and the kids hit them as the heads pop up. And so basically you're just hitting all the different test points and testing. You're not doing any, and when it's green, it's green. When it's red, you got to retest it and see if you can, resolve whatever that issue is. And so from that perspective, you can take that information, put it into analytics like BI tools. So you use things like Power BI or whatever sort of analytic software that you use. So we can parse the data and get the data together for you. And if you have your own internal system that you use, you can tie that data and parse it and then dashboard it any way you want, right? And so there's a lot of different ways to look at it. You can filter the test, based on a region. So I can say, okay, how much was done in Texas today? Or how much was done at this specific project? Is it 20% done? If you're looking at individual contractors or individual technicians, you can see, okay, who's where and who's doing what type of a thing and how far along are they? So you can queue them up for their next work. As a contractor, that may seem like, Big Brother watching over you, but at the same time, it prepares the provider to line up the next job. Like, okay, they're getting close to being done. Let's get this next section up and running earlier. And those types of things that happen. And of course, from a fleet inventory management, because we know what the test set is and the serial number and what it's doing, we can look at the fleet to see, hey, how many test sets are there? Are they within calibration? How long until calibration? Are they aging out? Should I pull that and write it off and get another one? All that can be tracked as well. So once we have that information in the cloud, there's a lot of things we can do. We can give specific filtered information to specific people, get closeout packages. We can do real-time analysis, over with tens and tens of thousands of results and get it into a deliverable package. And then all of this happens, right, with the, with all the cloud and you can even create custom jobs with external tools like Fast Reporter if you'd like, or you can have it automated through the automation. And so basically, we talked about the different test methodologies that we're seeing in the field and how those work and some of the challenges with all the high density stuff. And then of course we've got into the automation portion here at the end where we talked about how do we, enable the technicians in the field to be more efficient. So they're doing less typing to make less errors because they didn't increment something right, because they retested or they moved. It's easy to make these mistakes. And when you scale it by tens of thousands of connections, quite frankly, you're standing in front of the panel, just plugging in, plugging out, and it becomes a little, sometimes mind numbing, to think about that. And so some of the tools that we talked about that we talk about that kind of handles that we can send you more information on are PXM LXM Pro, which is our multi-fiber connection. This one actually has a removable swap out connector. So we can go from NPO to duplex LC. So really good for like one cord referencing standard situations. And then the Fiber Inspection Pro FIP 500, that's our multi-fiber. This also does single fiber as well. And then of course, there's a lot of different physical layer testing stuff out there that if you want more information, just reach out to us, ElectroRant, to get that. And so here is our information here. We're right up to the 1 minute away from the end here. And so I, yes, the activate Windows is driving me nuts too. I installed this last week and it won't take it wants me to disable my previous product code before I enable this one. So I need to do that today. So software packages do you recommend to manage and organize the results once downloaded from the tester? We have Fast Reporter 3. So I work for EXFO. I like Fast Reporter 3. I know a lot of people on here use it. It's free. So, if you go to exfo.com, Fast Reporter 3, and it's actually attached to our cloud infrastructure. And so you can manage any SOR. So if you have a third-party SOR, we can manage those results as well. If you need custom reports, just reach out to me. Again, my email's up there at the top. Multi-core. We have started seeing multi-core fiber. Not I haven't worked with it from a deployment perspective as much, more of a trial perspective, but it's there, right? Um, multi-core, hollow core, some of these new innovations are out there. I think multi-core is interesting because within 125 micron cladding, and there's probably different design considerations within that 125 micron cladding that we have today. There's one single, 8 to 10 micron single fiber. In multi-core, it's the 125 micron cladding with multiple cores within that 125 micron cladding, which is just amazing to think about. There's some considerations there as well, but that's a whole different subject. We wouldn't ever want to talk about that. Advantages of multi-mode APC. The only advantage would be if there's any ORL considerations. It's much less of an issue with multi-mode. And so we'll see where that goes. That's a fairly new trend that we're seeing. So when using large count loose tube sheaths, what is the color code for going past 144 fibers? That's not a simple answer. So I need a table for that. And so I haven't spliced since the 30S, so it's been a while. I mean, I understand it, but I haven't spliced since the 30S. So with that, we've reached our time, and so I'd like to thank you, and then hand this back over. Let me stop sharing here.
Thank you.
Okay.
Kevin,
Yeah,
thank you so
absolutely.
much. Thanks very much for that presentation. You answered the questions that came in. Thanks everybody who joined us. I know that we've hit and then exceeded the hour. If you've got a drop, understood. Thank you very much. I'll keep you for less than one more minute with my thanks to EXFO and to Electro Rent, to Kevin and Alon who delivered today's presentation. And just a reminder to those of you who joined us today, we have applied to Bixby for a continuing education credit for this seminar. If Bixby does in fact allow us to offer you a continuing education credit, no further action is needed by you. We will reach back out to you as an attendee today and deliver you an attendance certificate that Bixby will recognize. Our thanks go to EXFO and Electro Rent for their sponsorship, to Alon and Kevin for this terrific presentation, and of course to you, all members of our audience who joined us. We hope that we see you back here again sometime for some more learning. Really appreciate what Kevin offered to us today, and Alon as well, and wish you all a great rest of your day. Thank you all once again.
Thank you.
Thank you.